Now I will talk about cyclotron. What is cyclotron? It is a device. Cyclotron is a device. It is a device used to accelerate charged particles like protons, neutrons, alpha particles to very high energies. It is a device used to accelerate charged particles like protons, neutrons, alpha particles to a very high energies. Here, charged particles move along a spiral path under, a, under the action of a perpendicular magnetic field and gain energy as they cross an alternating electric field again and again. I am repeating once again. It is a device used to accelerate charged particles like protons, neutrons, alpha particles to a very high energy. Here, charged particles move along a spiral path under the action of a perpendicular magnetic field and gain energy as they cross an alternating electric field again and again. Cyclotron frequency. What is cyclotron frequency? In a cyclotron, the frequency of the applied alternating electric field is equal to the frequency of revolution of the charged particle. And this frequency is called cyclotron frequency. And this frequency will be equal to Fc. Cyclotron frequency Fc equal to Qb upon 2 pi m, where m is the mass and q is the charge or the positive ion. M is the mass of the positive ion and Q is the charge of the positive ion. The cyclotron frequency is independent of both the velocity of the particle and radius of its orbit. It does not depend on the velocity of the particle and the radius of the orbit. Maximum energy gained by positive ions. Maximum energy gained by positive ions. If V0 and R0 are the maximum velocity and maximum radius of the circular path of the positive ions in a cyclotron, then mv0 square upon r0 equal to qv0b, and the velocity v0 equal to qbr0 upon n. Then maximum kinetic energy will be equal to half mv0 square, and it will be written as q square b square r0 square upon 2m, where v is the accelerating potential of the high frequency oscillator and the charged particle completes n revolutions the before leaving the disk, and the maximum kinetic energy will be equal to 2nqv. Now, force on a current carrying conductor in a magnetic field. Force on a current carrying conductor in a magnetic field. A conductor of length L carrying current I held in magnetic field B at an angle theta with it experiences a force, and this force will be equal to BIL sin theta. Force between two parallel infinitely long current carrying conductors. Now I will talk about force between two parallel infinitely long current carrying conductors. The force per unit length between two long parallel conductors carrying currents I1 and I2 and separated by a distance r is given by F equal to mu 0 upon 2 pi I1 I2 upon r. Now, force between two current elements. With force between two current elements. What is the force between two parallel current elements dL1 and dL2? dL1 and dL2 are current elements, and these current elements are carrying currents I1 and I2 separately by a distance r. The distance between them is r, and two current carrying elements are dl and dl1 and dl2, and the currents between them is I1 and I2. Then the force will be dF equal to mu 0 I1 I2 upon 4 pi into dL1 into dL2 upon R square. Again, once again, dF equal to mu 0 I1 I2 upon 4 pi dL1 into dL2 upon R square. Now I will talk about torque on current carrying coil in a magnetic field. Torque on current carrying coil in a magnetic field. A rectangular coil of area A carrying current I and capable of rotating about an axis perpendicular to the field B experiences a torque. That torque will be equal to tau equal to NIBA sin theta, and it can be written as also MB sin theta, where N is number of turns in the coil and small m equal to NIA, and NIA is magnetic dipole moment. And theta, what is theta? Theta is the angle which the normal to the plane of the coil makes with the field B. Moving coil galvanometer. Now I will talk about moving coil galvanometer. What is moving coil galvanometer? It is a device used to detect current in a circuit. It is based on the principle that a current carrying coil placed in a magnetic field experiences a current dependent torque, which tends to rotate the coil and produces angular deflection. It consists of a coil of wire of area A and N turns carrying current I to be measured. It is suspended in a radial magnetic field so that its plane always remains parallel to vector V. By a suspension fiber of torsion constant K. In equilibrium position, it will be equal to alpha equal to NBA upon K into I, meaning that deflection of coil is directly proportional to the current in the coil. In the figure, you can see the galvanometer. Now, current sensitivity of a galvanometer, current sensitivity of the galvanometer. It is the deflection produced in a galvanometer when a unit current flows through it, and current sensitivity will be equal to alpha upon I, and that will be NBA upon K. Now, voltage sensitivity of a galvanometer. It is a deflection produced in a galvanometer when a unit potential difference is applied across its ends. Voltage sensitivity will be alpha upon V, and it will be written as alpha upon IR, and it will be written as NB upon KR. Now, conversion of a galvanometer into ammeter. If I want to convert galvanometer to ammeter, then an ammeter is an instrument used to measure electric current in a circuit. A galvanometer of resistance G can be converted into an ammeter of range 0 to I, connecting a small resistance S in parallel with it. The value of small resistance called shunt, and it is given by S equal to Ig upon I minus Ig into G, where Ig is the current with which galvanometer gives full scale deflection. Total resistance of an emitter will be equal to Ra equal to Gs upon G plus S. An emitter is a low resistance device and is connected in series in a circuit. Now, conversion of a galvanometer into voltmeter. Galvanometer can be converted into ammeter, and galvanometer will be converted into voltmeter also. A voltmeter is used to measure the potential difference between any 2 points of a circuit. A galvanometer of resistance G can be converted into a voltmeter of range 0 to V by connecting a large resistance R in series with it, and it is given by R equal to V upon Ig minus G. The total resistance of a voltmeter will be Rg equal to G plus R. A voltmeter is a high resistance device and is always connected parallel to the conductor across which potential difference is to be measured. If you like my video, please like and subscribe my channel. Thank you.